This will be a hypothesis test for proportions, and here's our situation. So, like a lot of Americans, John Wayne died of cancer, but is there more to the story? In 1955, Wayne was in Utah shooting the film The Conqueror. Across the state line in Nevada, the U.S. military was testing atomic bombs. Radioactive fallout from those tests drifted across the filming location. A total of 46 of the 220 people working on the film eventually died of cancer. Cancer experts estimated that one would expect only about 30 deaths in a group this size. So our goal is to perform a hypothesis test to determine if the death rate amongst the movie crew was unusually high, and does this data actually prove that exposure to increased radiation causes cancer? So I'm going to organize this in Excel and show you kind of the thought process and mathematical symbols as well as some descriptions of what's going on. So the null hypothesis is always a statement of what the masses believe. So in this particular case, our null hypothesis would be that the true proportion of cancer is going to be 30 people out of 220. We're going to go with what the experts believe. So in words, the null hypothesis is that the experts are correct and the true proportion is 30 out of 220 cancer-related deaths. Okay, now the alternative hypothesis should be based on our new information. So our alternative hypothesis is that the true proportion is actually greater than this. Oh goodness, sorry about my typos here. Okay, so the alternative hypothesis is that the true proportion is actually higher than 30 out of 220 cancer-related deaths. So let's build some basic statistics on the information that we have. So the sampling distribution is what we need to build here. So we have a sample size of 220 people. The assumed mean comes from the null hypothesis, because we're trying to determine if that's actually a reasonable mean. So that is 30 out of 220. And since the decimals may hide that for the rest of the video, I'll write it here too as well. Now the standard deviation comes from the standard formula for calculating a standard deviation for a proportion. So this is square root of the mean of our sampling distribution times 1 minus the mean over sample size. So the standard deviation is quite small. The assumed mean is based on what we assumed from the null hypothesis. I'm calling this a standard deviation because we assume that we actually know something about the population. Now, our sample, on the other hand, gives us new information about this situation. So our sample, the proportion is 46 out of 220. So we had 46 cancer-related deaths out of 220 people working on the film. Now, to calculate a p-value, what we're interested in is what is the probability of finding our sample or more extreme? Now, the sampling distribution will be normal in this case because we're estimating something that's truly just proportions. So this is, well, let's see, our sample's high and we want to go more extreme, so 1 minus normal distribution of our proportion, the one that we found, with our assumed mean our standard deviation based on the assumed mean, and of course always accumulate. So the probability of finding our sample or something more extreme is 0.0008. So that is 0.08% chance. Now, we are simply just not that lucky. Right? We're not so lucky as to just find this sample by random happenstance. So our conclusion is to reject the null hypothesis. And what this tells us in words is that we have sufficient evidence to believe that the true proportion for the movie crew people So we have sufficient evidence to believe that the true proportion of cancer-related deaths for the movie crew was actually higher than what cancer experts believe. So, okay, this is awfully wordy. Let's see if that actually makes sense for us as far as being able to prove that exposure to radiation increases the risk of cancer. Well, this is a tricky word. To be able to actually prove that, we would have needed to do some sort of controlled randomized experiment, and this was certainly not a controlled randomized experiment. So, this does not prove anything about the exposure to radiation. So let's go back through the ideas one more time real quickly. The null hypothesis states something about what we are assuming to be true in the population. The alternative hypothesis is something that states an alternative to that, basically usually something that we are trying to prove or trying to establish as the new truth. The sampling distribution is based on the assumed information. So we have a sample size, we have the assumed mean, we have the standard deviation based on the assumed mean. We have our particular value that we found in our sample, and the p-value comes from using the normal distribution to calculate the probability of finding our sample or something more extreme. If you are more extreme than a 5% chance, usually 5% are cutoff, then we reject the null hypothesis, which says, hey look, the null hypothesis might not actually be true, but since this did not come from a randomized controlled experiment, we do not actually have evidence to say, look, let's just reject it and say that radiation caused all of these deaths. We do not have that information. I hope this has been helpful.